This is the third video on this introduction to building a robot in VEX parts, using VEX parts. And so we're talking about wheelbase and wheel track, the definitions of wheelbase and wheel track, and the advantages and disadvantages of the ratio of wheelbase to wheel track. The robot with a long wheelbase and a shorter wheel track ratio will go straight but be more difficult to turn, right? So short, wide robots turn easily. Long, narrow robots will not turn easily but will have more of a tendency to drive straight. So you have to, in your design, you want to, depending on what the requirements are, you can balance those two things. Just wanted to quickly show an interesting robot here with an articulating suspension, and you can see that this robot, you actually have control over both the wheelbase and the wheel track, right? These can be extended out, and so there's lots of different configurations that this robot can be operated in. So here you have, using this type of steering, you have a sharper angle for the inner wheels than you do for the outer wheels. So this would be called, it's kind of a Ackerman type steering. And on the other hand, if you have both wheels just going straight, like in this one, you can do the skid steering, which is the type of steering you'll do in your robot. So here you have this dual Ackerman, where the wheels are turned, and as I said, the inner wheels are actually turned more than the outer wheels because they have to follow a tighter circle, a circle with a shorter radius, smaller radius. Or you can turn just by keeping the wheels going straight, but in this case you can just spin in place. But the difference, of course, is that this is just a picture of that robot with the wheels stowed, brought in. You can see here's the skid steering, here's the explicit steering. And you can see, especially as the radius of the turn gets smaller, the skid steering just requires a lot more power. So it's certainly simpler to build, but it does require more torque to do the turn. So next we'd like to talk about the importance of supporting the shafts with bearings. So in this particular case, this picture shows, just having the shaft run right into the motor and just using the motor to support the, in this case, a wheel. Generally, that's not a good way to do it. If you have one bearing, if you exert a force on the wheel, you can still see that you can still transmit some force back to the motor. So ideally, what you want to do is either have a bearing on either side of the wheel, or if you can't do that, if the wheel has to be cantilevered out, outside the robot, well, then you can still have a structure where you at least run the shaft through two bearings. So that way the bearings are supporting the radial loads from the shaft rather than the motor. The only thing you want the motor to do is just to supply the torque or the twisting action to turn the shaft. You don't want it to actually support any lateral or radial forces from the shaft itself. And so here's one way to do it. So in this case, let's see, you can see that we have a bearing right here, right? These two screws just help, attach the bearing to the piece of metal and also support the motor. And then you have the shaft is at least running through one bearing. But a better yet way to do it is to have some kind of structure so that you can have a bearing on the other side as well, which may or may not be possible, but this reduces, again, the radial load on the motor itself. So next we're going to just, I'm going to go briefly through some of the VEX parts, and then actually go to the VEX website and show you some of the information that's available there. So you can see we have different kinds of nuts. So this is Nylox nut. It has a nylon insert to keep it from loosening, and actually I'm going to have to stop here and pick up with the next video.